All right, now that we have a sense of bank account and how we can use the runner to change the instance that we're working with, let's take a look at the person class. So the person class is declared here. In its body, we have our instance variables, and we have two. We have a name and an account. And name is just a string, and account is a bank account. And this was the class we were looking at before. So what we're saying is every person in this program is going to have a bank account, and its name is just account. We can name our variables whatever we'd like. Our constructor is different from bank account's constructor in that it has a single parameter here. So we're requiring a parameter, and I had changed this before. Yours is going to say string name as the parameter name, but remember what we name our parameters can be anything. So this could be XYZ, and this would still work just fine. But I'm going to leave it at name. So what's going on here is what we're saying is to construct a new person, to instantiate a new person, we have to give the constructor a name, and that will be something like the string Chris or the string Carol. We're going to take that name parameter that you give us, and we're going to assign it to our instance variable named name. And that will store it with the instance, so for as long as the instance is living, it's going to have a name. And if you watch Dorian's video on constructors, which I think is really good, this idea of the constructor is comparable to like the birthing of a baby. A baby doesn't have a name until you give it one, and so this is how we, in this class, are giving a name to a person. We're also saying every person has a bank account, and we are going to initialize our account instance variable to a new instance of the bank account class. This will say we're setting up a new bank account and assigning it to account. If we didn't do this, we would later see some null pointer exceptions, kind of like we saw in problem set 2. When you go to, say, get a paycheck, if account hasn't been initialized to a new bank account, then we would get a null pointer exception when we tried to send this method call to something that hadn't been set up yet, to a bank account that didn't exist, right? So that's our constructor. And then we have our methods. And so we've got a few methods here, void gets paycheck, and what we're going to do is we're going to say, hey, in our instance variable named account, we're going to deposit $2,000. If we go to Rams for dinner, we're going to withdraw $12 from our account, and then we have some getters where we can check the name of this person and get the bank account of this person back. Okay, so I'm going to save this. I'm going to jump back over to the runner, and so the runner is set up to be working with a bank account, but we're working with a person now, so why don't we change that? So why don't we say person 0 equals new person, and assign to our instance this person 0. But oh wait, we've got an error here, and what's the error? It's saying the constructor person is undefined. That's right, we have to give a person a name because we specified that it requires a parameter named name, so we need to give it an argument that will be its name. So I'm going to give it Chris as an argument. Okay, so now we've set up a person named Chris, and our instance that we're going to be working with in this user interface is drawn right here. So I can check, there's Chris, and I can get a bank account, and notice that we get a new window, and this is a bank account instance, and we can check the balance of that. It's currently 0. If I get a paycheck, remember what happens here is P0 that gets paycheck is calling get paycheck on my instance, and if we jump over to person, we'll see that the get paycheck is saying, in my bank account, go deposit $2,000, right? And so if I check my bank account's balance now, I should have $2,000 in it. If I go to Rams for dinner, I'm going to have $12 less. If I go to Rams for dinner a few times, I'm going to have quite a few dollars less. And this is how we can start to get a sense that by changing the instance we're working with in our runner, we can start interacting with an object over here in a different way. And now we can start to play with this person in code. So we can say something like, actually before we do that, let's look at what it would take to make a setter that allows us to change the name of a person. So currently this person class does not allow us to change its name. Let's say we wanted to make that possible. We could add a method that is something like void set name with string n is what we use as our parameter name, or we could use name. I'll use name because that's sort of convention. What we're saying is whatever name that we give to this set name method call, we are going to assign to our instance variable named name. So let's think through this for a second. So if I go and I run this, we'll see that the instance that we're working with starts out with a name of Chris, but now we've got this new setter method available to us. This is similar to what you're having to write in the current problem set. And if I set the name to, say, Jackie, and call this method, what happens is when I call this method, we're taking the string argument named whose value is Jackie. We're going to pass it in, and so name will become Jackie. This name variable now has a value of Jackie, and so we enter the method, and we're saying Jackie, assign that to our instance variable name. And so what we've done is we've changed the instance variable of this person named name. And so now if we go and ask for the name, what is the current value of name? When we call this getter here, we're going to return whatever value is currently stored in name. So we can change that, and that's the point of a setter, is the ability to change properties or instance variables of an object. So I could change this to Carol and call this method, and we'll see that now Carol is the name that we're getting back. And you've actually used these before. These setters are what you were calling to change the properties of shapes in Baymoji and problem set 2. And so with a setter, again, we're specifying a parameter that allows you to give us that little extra piece of information. What is the value that you want me to change my instance variable to? And so when I receive this message with whatever that value is, I'm going to take it and change my instance variable. So the next time that you go and you ask me for what is the current value of that instance variable, and I return it to you, it's going to have whatever you last set it to. And a similar thing is happening in bank account, where we were changing the values of our balance instance variable with 2 different methods, deposit and withdrawal. So that's how we work with a setter. And we could actually do this in code too, right? So we could say person0.setName to be Carol here, and we could say person0.getsPaycheck. And since we're working with Carol, why don't we just, for fun, throw in a loop that allows her to get quite a few paychecks. So while I is less than 100, Carol just makes straight cash. We're going to loop this code 100 times, but we have to make sure that we increment I so that each time this runs, I will increment, and then eventually after it's run 100 times, this will no longer be true. So now we're working with a person whose name was initially set to Chris, but we changed it to Carol, and then Carol got just a crap ton of money. So we say, hey Carol, that's her name, and we check Carol's bank account now, and she's got 200K in it. It's a good month for Carol, and things are going well. And we can see that we can work with this bank account in a similar way. So what the problem, actually I'll talk about the example problems from the slides in the very next video. What we saw here is that we can change the instance that we work with in our user interface, and we talked a little bit about a setter and what it means for a setter method to change an instance variable's value, and then a getter to read the new value back out. And again, we're seeing that what we're doing in that user interface feels clunky because it's simulating what the code we would have to write in order to interact with these instances. But it's worth knowing that we are actually interacting with the instances we set up in our code.